Now the next, adding ammonia and amines. Ethylene oxide reacts with ammonia forming a mixture of mono, di, tri, ethanolamine. The reaction is stimulated by adding a small amount of water. The reaction is CH2CH2O plus NH3. It gives HOCH2CH2NH2. On increase in concentration, in case 2CH2CH2O plus NH3, it gives HOCH2CH2 whole twice NH. It gives HOCH2CH2 whole twice NH. On further increasing the concentration, the reaction is CH2CH2O plus NH3, it gives HOCH2CH2 whole thrice N. Similarly, proceed the reaction with primary and secondary amines. The reaction is CH2CH2O plus RNH2, it gives HOCH2CH2NHR. Dialkyl aminoethanols can further react with ethylene oxide forming aminopolyethylene glycols. The reaction is NCH2CH2O plus R2NCH2CH2OH. It gives R2NCH2CH2O, CH2CH2O to N times H. Next, trimethylamine reacts with it. The next, trimethylamine reacts with ethylene oxide in presence of water forming choline. The reaction is CH2CH2O plus CH3 whole thrice N. This is a tertiary amine plus water. It gives HOCH2CH2N CH3 whole thrice OH. This is choline. Aromatic primary and secondary amines also react with ethylene oxide forming the corresponding aryl amino alcohols. Now next, halide additions. Ethylene oxide readily reacts with aqueous solutions of hydrochloric acids, hydrobromic acid and iodic acids to form the corresponding halohydrins. The reaction occurs easier than the last two acids. The reaction is CH2CH2O plus HCl gives HOCH2CH2Cl. The reaction with these acids competes with the acid catalyzed hydration of ethylene oxide. Therefore, there is always a byproduct of ethylene glycol with a mixture of diethylene glycol. For a cleaner product, the reaction is conducted in the gaseous phase or in an organometallic or in an organic solvent. Ethylene fluorohydrin is obtained differently by boiling hydrogen fluoride with 5 to 6% solution of ethylene oxide in diethyl ether. The ether normally has a water content of 1.5 to 2%. In absence of water, ethylene oxide polymerizes. Halohydrins can also be obtained by passing ethylene oxides through aqueous solution of metal halides. The reaction is CH2CH2O plus CuCl2 plus 2H2O. It gives HOCH2CH2Cl plus CuOH whole twice. Now the next, addition of organometallics. Introduction of ethylene oxide with organometallic compounds, which are the Grignard reagents, can be regarded as the nucleophilic substitution influenced by the carbanion. Organometallic compounds can be regarded as nucleophilic substitution influenced by the carbanion organometallic compounds. The final product of the reaction is a primary alcohol. The reaction is CH2CH2O RMGBr or RMGX. It gives the R CH2CH2O MGBr or MGX, which on further hydrolysis gives RCH2CH2OH. A similar mechanism is valid for other organometallic compounds. For example, CH2CH2O plus RLI plus, it gives the reaction is the CH2CH2O plus RLi. It gives RCH2CH2O Li, which on further hydrolysis gives RCH2CH2OH.